tension. And then experiment, they have cases for straw immersed in water and above water surface. So they have several parameters, and thus the theory and experiment agree the lack of comparison. And here's the remarks of the reporter. They have clear force analysis, and for the suggestions, they didn't define pumping speed clear, and we think that the voltage is not that important in popular. We think what important is the angular velocity, and we think the comparison between the theory and experiment is not like obvious. Okay, so there is the remarks to the opponents. They have investigated meaning of trend line and clarified errors in data and meaning of flows, and they identified that the theory is wrong. And their suggestion for this suggestions, they didn't clarify the definitions of pumping speed first, and they shouldn't spend too much time on the cosine theta. Okay, so here is our discussion. So I asked both of them what is the definition of pumping speed, and the reporter talks about the x velocity, and the opponents talk about the volume pumping out per second. And in our opinion, we think the mass flow rate is important, but the excess velocity can also be used to describe the pumping speed. And this should be discussed early, because this is most important. And we asked if it's important to measure the voltage as I mentioned before. And we will ask is we think that the water level changing during the water being pumped out can use like a water supply to control the water level. And we consider the Bernoulli's law is important due to it caused the pressure difference that we agree with the opponent. And we asked this the area of the bottom of the. So here is some list points. We think they should have clear definition of pumping speed. And for the reporter, the analysis of voltage is not that important. And the angular velocity is important and should be discussed more. And the comparison between experiment and theory should include in the presentation. And we should talk about how to correct the theory considering friction. I think that's all. Oh. Okay. So I just skip it. So the advantages to the reporter is
okay.
And this is my conclusion remark. And first, I want to thank the opponent and the reviewer. And the response for the opponent, the first is in a short question, he asked me that the trend of the light, and I want to respond in here. And the bright light opponent said is the trend light, and the colorful light is our experiment data. And the second one is we did have a relationship between the three-cost models and experiment data, and had the error bar on its track is initial angular velocity. And the third is and actually at first I didn't really understand which plot angles the opponent means, but after I realized and I had a fault here, and we will improve and correct a little error in here. And I think the definition of the pumping velocity and the speed in our track here is not really important, and because we just want to observe connect with the experiment data and the theory model. And response for reviews, I think the primary principle is not important in this phenomenon because of it's only suitable for ideal situations, and we did use. And the second one is we have to connect with the theory and the experiment data. And the third one, I think the voltage is important because we would like to try different parameters of it. And in my conclusion, I mentioned that the key of angular pumping speed is angular velocity, and the river has mentioned that. And I think the voltage is the most direction to control the angular velocity, and it can prove that our trend. And so the voltage in here is a very important parameter in our presentation. And thank you for your attention.
Okay, it's time for Julie to ask questions.
Please turn to page 11. I see this term in the y-axis. You use initial angular velocity.
Here.
What do you mean by initial? So is your angular velocity stable or not?
No, it's not stable. And in here we do an experiment, and we take the front of the video like the 3 seconds, and we check the angular velocity with the stroke, and we take an average, and to make this chart.
So it means that your angular velocity is increasing as function of time.
This picture is tell that voltage increase and the initial velocity will increase. And you said that stable, and we have already mentioned in just like this, it's a stable. This angular velocity is the whole video on it, and you can see because of the water level is pumping, the water is pumping out, and the water resistance is decreased, and the angular velocity in here will decrease.
Okay. So in the first few 40 seconds, speed is stable.
Yes, because you can see here's a line here, and I write here is equal to the
Okay, thank you.
piping net.
I have one question to the opponent. Actually, you spent much time on the discussion of the theoretical model or parameter of definition. Do you think there's any missing point in the experiment part?
For which experiment?
That's my question. Do you think there's anything you want to discuss, or you think you missed, or
I
you
think
can just say no or it's fine?
I think that's the comparison to the theoretical lines and their data needs to be fixed because because of the theoretical model, they have a lot of some mistakes inside. So maybe after they change the theoretical data, a theoretical model, they'll have another trend or another definition of their experimental data.
Why the curve goes to situation in this your every experimental
Always
data
stop at
always
300.
goes to situation.
Saturated is 300.
Because of we let immerse depth in the sand, and we have a container, and so it's almost in here is it hasn't water can pumping out, so it will stay in here, and you can see that
So means your container is empty now.
here you can see the button in here. So it in this chart it means this
Is no water going out?
yes, because of its pumping out, it's empty in here, in my container, so it can pump in
What time?
what time? In this part it has a different line in here. I think it's because just that observe that when the
Because I cannot see the word institution. Second is the unit, time unit is second. So
Yes.
2 minutes is goes to the part
because of our container is small, so it's pumping empty is yes. test.
Okay. And page 13. Is all the same?
Usually this
Yes.
it's because our battery effect that's observed that when the water level lower than the straw, it can also pumping out. So it means the edge of the water level is different.
Professor, time's up.
Okay, so now it's scoring time for the jury. Okay. So the score for the reporter. 6, 6, 8, 5, 6. The score for opponent. 6, 6, 8, 7, 6. The score for reviewer. 5, 7, 6, 6, 5. Okay, thanks for everyone. So that's
May I have a short comment to the reporter?
yeah.
It's a pity that I can tell that you devote a lot of efforts in the experiment and you measure many things. And I can understand the setup and measurement is quite difficult. But it's a pity that you don't go into the details or analyze our discussion of the physics mechanism. I would say it's a little bit pity, yeah, for your part.
any more comment? Okay.
Also, I'm really interested in critical condition when the water pumping down, given the same configuration. For example, you increase the voltage of your power supply, and at what conditions the water start to pumping out, and then perhaps you should analyze. For example, the opponent mentioned the viscosity or friction, or even the reviewer mentioned the tension, the surface tension. So perhaps some of these factors may impact the initial or critical voltage or critical inverter speed.